Let's say that you're logging the database calls and all parameters on your prod instance so that later you can play it back in your test environment to see if your latest DB tuning effort gets better results. As beginners, we may start out with code like this. And don't get me wrong, it works great for the first few, but what if you want to add a third parameter or you want to log that massive procedure with 30 parameters? Suddenly your simple function is mutating into its own kind of nightmare. The kind of code you wish you could unsee. And yes, you could make it match the biggest proc you've seen, but there will always be a bigger one around the corner. Luckily, Python gives us packing and unpacking. It lets us keep the code small and elegant. We'll get there in a moment, but first, let's break down what packing and unpacking actually is. You've probably seen an example like this before. ABC equals 10, 20, 30 as a tuple. This is an example of unpacking, and it unpacks 10 into A, 20 into B, and 30 into C. And then there's packing, where we're just putting those values into the iterator. So in this case, it's a list, and we're putting in A, B, and C. If we take this code, A, B, and rest, and put in the values 10, 20, 30, 40, 50, we're going to get an error. There's simply not enough variables to unpack that data into. To the rescue, we have the packing operator, which happens to be an asterisk. When we put this in front of a variable, it tells it to pack in any additional numbers that didn't fit into the rest. So here, rest actually becomes a list of the numbers 30, 40, and 50. And do note that the packing operator doesn't have to be on the last variable. If I move it over here to B, and you'll see now that B is actually a list of 20, 30, 40, and Python has put 10 in A and 50 in rest. This will work fine for any real combination as long as you don't have more than one packing operator. If you have more than one, Python's got no clue what to do and it'll throw an error. What is really cool is the ability to pack values extends to Python's function definitions. So in this example function here, I'm putting the packing operator in front of the numbers variable. And this means that I can now pass in as many unnamed variables as I like. And Python will package them into a tuple called numbers. We can then pass this to the sum operator, which operates over an iterable and adds the numbers together, and we get these results. Now you may be thinking, but the database call you are doing has keyword arguments. This doesn't help me. Don't worry, Python's got you covered. It also has the star packing operator. This is used exclusively for key value pairs. You'll see in the code example on screen now, we have a function that takes args, comma, star kwargs. And you'll see this a lot because actually args and kwargs are the standard names you would give to these kind of variables. And it stands for arguments and keyword arguments. But you don't have to stick with those names. It's the star for packing iterables and the star for packing name value pairs that makes the magic happen. So if I call this function with the arguments of 1, 2, 3 and the keyword arguments of A, B, and C, what happens? Well, Python has created an args tuple and a kwargs dictionary. You now know enough to get back to our original problem. Here's a better version of the logging function using the equivalent of star kwargs. I'm calling it params because it makes more sense in my use case. You can see I'm now passing in a ton of keyword arguments and the function can just handle it. In fact, it can handle any number of them. No more nightmare function signatures. And now we're about to get even better. Most DB libraries accept parameters as dictionaries already. Just like you can use star to pack name arguments inside a function, you can use star to unpack a dictionary when calling it. This means that our log DB call can now just take star DB params and it will unpack that dictionary into keywords and then pack them back in the function call. This has all kinds of applications for actually scheduling calls to happen. You now just need a list of dictionaries or tuples and you can call a function recursively. That means to simulate real database load on production, I can just schedule these for each minute that the call really happened in real time and push them into the system. Packing and unpacking really does start to let you write more flexible, reusable functions with less code and less effort. What you've learned in this video is perfect for logging, debugging, or building decorators. And speaking of decorators, in the next video, we're taking this even further. I'll show you how to extend your function's abilities without touching its code. We're talking Python decorators. And yes, they rely heavily on the packing and unpacking you've just learned. You'll find that video top left right now. Go check it out. Thanks for watching, and I'll catch you on the next one.